Let's see ring counter. As the name suggests, if one of the bit is given to the flip-flop, when one bit is set and other bits are reset, the set bit rotates in the form of ring. Okay? If high or preset pulse is given to A flip-flop and clear pulse is given to B, C and D, then output of B, C and D will be 0, 0, 0, 0, 0, 0, and preset pulse is given to A flip-flop, so output of A will be 1. So this one rotates in the form of ring and it is shifted towards left side at each clock pulse. See, when first clock pulse arrives, it rotates from A to B. Then for second clock pulse, it rotates from B to C. Then C to D. Then again it returns back to A. Then again A to B, B to C, C to D. So this bit rotates in ring formats. That's why this type of counter is known as ring counter. Now let's see the construction. Here it uses 4 types of D flip-flop, or we call it as data flip-flops. Okay, so here ring counter uses 4 D flip-flops. See, output of first flip-flop is given as input to second, output of second is given as input to third, and output of third is given as input to fourth, and output of fourth flip-flop is given as input to first flip-flop. So just bit rotates, output rotates. Here see, ring fashion is there, so that's why this is known as ring counter. So as I told you, first preset pulse is given to only first flip-flop, which is A, and clear pulse is given to second, third and fourth, or B, C and D flip-flop. So initially output will be 0, 0, 0, 1, 0, 0, 0, 1. See how clock is given? Clock is positive edge trigger, bubble is not there. So output will change when positive edge is arrived. So at each positive edge, output will change. So initially, see, output is 0, 0, 0, 1. 0, 0, 0, 1. So when first clock arrives, then output changes. So output becomes 0, 1, 0, 0. See, output of A will become 0, output of B will become 1. So this A will come here. So 0, 1, 0, 0. Or if we read it from here, 0, 0, 1, 0. 0, 0, 1, 0. Then when second clock pulse arrives for second positive edge, this 1 will move here. So output will become 0, 1, 0, 0. See, this is 0, 1. This becomes high. 0, 0. 0, 1, 0, 0. When next clock pulse arrives, this 1 rotates here. So output becomes 1, 0, 0, 0. 1, 0, 0, 0. So 1, 0, 0, 0. When next clock pulse arrives, this one will enter here. So output will again becomes 0, 0, 0, 1. See, 0, 0, 0, 1. So this is how the ring counter works. So as we have seen, at the end of 4th clock pulse, output of counter becomes DCBA equal to 0, 0, 0, 1, which was the initial stage. Okay, so this counter is known as ring counter because store bit follows the circular path moving in left direction through the flip-flop until bit stored in the last flip-flop returns back to the फर्स्ट फ्लिप-फ्लॉप. जसं इथे आपल्याला मिळालेलं आहे. सो रिंग काउंटर इज यूजफुल टू कंट्रोल सिक्वेन्स ऑफ ऑपरेशन इन मेनी डिजिटल सर्किट. सेम सिक्वेन्समध्ये एखादं ऑपरेशन पाहिजे असेल तर आपण काय करू शकतो, वी कॅन यूज रिंग काउंटर.